Okay, hi. Good morning to everyone and welcome to the Gate Mentor Academy. आज हम लोग नया टॉपिक डिस्कस करेंगे. इट्स थ्योरी ऑफ मशीन. इट्स अ वेरी वेरी इंपॉर्टेंट टॉपिक फॉर गेट पॉइंट ऑफ व्यू. सो देखिए, थ्योरी ऑफ मशीन दैट कम्स अंडर द डिजाइन पार्ट. देखो, गेट मैकेनिकल को यहाँ पे दो पार्ट में डिवाइड किया गया. एक थर्मल पार्ट है और एक डिजाइन पार्ट है. थर्मल पार्ट में यहाँ पे थर्मोडायनामिक्स, पावर इंजीनियरिंग, हीट ट्रांसफर एंड फ्लूइड मैकेनिक्स, टोटल 4 टॉपिक आते हैं. And in design there is a total 5 topics are there. That is the strength of material, machine design, production engineering, industrial engineering and theory of machine. तो जो आज हम लोग डिस्कस करने वाले हैं इट्स द थ्योरी ऑफ मशीन. And from this topic 4 to 5 questions every year in GATE system, and that is 8 to 10 marks. तो हम लोग यहाँ पे आज स्टार्ट करेंगे एंड इसमें सब टॉपिक हम यहाँ पे नोट कर दिए. एंड द सब टॉपिक्स आर हियर. मैकेनिज्म इज द फर्स्ट टॉपिक. इन दैट वी विल डिस्कस अबाउट द लिंक, पेयर, चेन and degree of freedom. These all the things. And next is a velocity and acceleration analysis. Next, instantaneous center, per gear, gear trend, and time and forward. So we'll focus basically on these 5 topics. From these 5 topics, any 4 questions you got. It's okay. Mechanism 1 question, velocity analysis that is 1 question, instantaneous center 1 question, gear trend 1 question. So total here 4 questions are there. So we'll start that here. So it's a mechanism. So in mechanism, first of all, we will discuss theory of machine. In that theory of machine, in that the first is a link, and that link is named as a kinematic link. Kinematic means it is in motion. So what is mean by link? So link means there should be a some relative motion with respect to some other part. Some other part. That is the first point. The second point is it should be a resistance body. It should be a resistant body. Resistant body means it should be a rigid body that can transmit power and motion. That can transmit power or motion from one link to another link. It should not be flexible. Another link. The link could be here any type of link. Like if I say example here, like a pulley and a belt. These are the two pulleys are there, and over that the belt is here. Belt is wrapped. So this one I am assuming that driver, and this is the driven, that is rotating through. Yeah, rotating with the help of driver. So this is called a link. Link, which is the connecting between the 2 points, or it should have a relative motion. So this link is in relative motion, or it's in moving. So this is here. This link is actually a rubber band, and this rubber band could be flexible. Flexible, and it is transmitting the power, but it is a flexible. But if you are going to make it any machine, that link should have a rigid body. It should not be flexible. Why it is a flexible? Can break. It can break. So we have a different types of link, like types of link. That the first one is a rigid link. Rigid link. It should have a relative motion, and the second, it should not deform. Should not deform. Not deform. And what is the example? Example is a crank. It's a rod, or we can say that it's a connecting rod, or it's a piston cylinder. So these are the called here rigid link. Similarly, the next is here flexible link. Flexible means I can say that this is the example, like a drive. Which drive? It's a belt drive. Yeah, we can say that chain drive. Yeah, we can say that rope drive, chain drive, rope drive. These are the flexible links, means which can deform, which can deform. And one more type of link is there, that is the third one. It's the fluid link. Fluid link. And fluid link means, remember that the power is transmitted with the help of fluid pressure. The power is transmitted with the help of fluid pressure. That is important. And the example we can say that hydraulic current, hydraulic crane, or we can say that hydraulic jack, or we can say that hydraulic ram, or hydraulic pressure. And how the hydraulic jack look like? So it should have like that. This is the hydraulic jack. And there should be a ram. This is called a ram, and this is your plunger. This ram area is capital A, this small is bigger. So here we will apply the here input force, we will get it here output force. F2 will get here. So this F2 is called here output, and this is called here input. And we are applying here a small force, and we are getting here a large pressure. So that is here hydraulic jack. So this is the here type of link which call it is here. And also remember that link means it should have a relative motion between the parts. So which type of relative motion is there? So relative motion, there is a different type of relative motion is there. Like relative motion means like it's a completely constant or unconstrained. So completely constrained and unconstrained means what? Completely constrained motion means there should be only one motion. There should be only one relative motion. Only one relative motion. Yani it should move in one direction. There should be a movement in one direction. And that movement is called here mechanism. Unconstrained means there is a motion is there that is a more than one direction, like 2, 3, 4, like you can say that more than one direction. So that is called unconstrained or inconstrained. So that is inconstrained means you won't get it here mechanism. There is a no mechanism. There is a no mechanism. You won't get it here if there is a more than one motion there. Similarly, the next we will discuss up here. So this is the important. You remember that what is meant by completely constrained and unconstrained motion. More than one direction. If the mechanism is moving more than one direction, that is called unconstrained. Next, we will discuss important is kinematic sphere. So the definition of kinematic pair is it's a connection between two links. It's a connection between a two links is always a joint or pair is always a joint or pair. That is called a kinematic pair. Or also we can say that if the relative motion between the links is constrained motion. And the second point, I can say that the relative motion between the link, it should have constrained motion. It should have a constrained motion. Should move only one direction. So there the two types of pair is there. Two types of pair. The first pair is called here, it's a lower pair. And the next is here a higher pair. Lower pair, it means it's a surface contact. And a higher pair, it means line or point contact. Line or at the point contact. So the lower pair example surface contact means I can say that it's a turning pair. Turning pair is a lower pair. Like if I'll give you the example here, lower pair. In the lower pair example, first of all, it is a turning pair. Like any link can turn about some point. Like I can say that this is the fixed one and one link I'm going to attach it. So this link can move in this direction or it can move in this direction or it can move in this direction. Like it can rotate or it can turn. So it is making here, it's a surface contact, it's example of turning pair. It's example of turning pair. And a turning pair is here we can say that it is a rolling, it means it's a pure rotation motion. Pure rotation. Pure rotation. That is here turning pair. Like we can say that example, it's a knee joint. Example is a knee joint. घुटना का जो joint है यहाँ पे, that is here it is a turning pair in our body. Second one is a sliding pair. Sliding pair is a pure sliding motion. Pure sliding motion. Pure sliding motion. Like I'm assuming that this is the here hole is there and there is one shaft is there. This is the shaft. And this shaft can slide. I'm assuming that it's a rectangle shaft. This is the here hole is there. So this shaft, this is the here shaft, and this shaft can reciprocate or slide, or it can move to and fro motion. So this type of it's making here surface contact. Next is a rolling pair. It should have a pure rolling motion. Pure rolling motion, it means this is the surface and over that one roller is rolling. Pure rolling motion without slipping. Without slipping. That is called here, it's a rolling pair. Next, I can say that the example is here screw pair. Screw pair. Nut and screw. Like example, nut and bolt. Fifth, a spherical pair. How the spherical pair look like? So look at here. There should be a one sphere, and so that a link is attached, and this sphere is rolling about this surface. So this is called ball, and this is called socket. It's a ball and socket, we can say that. Ball and socket. So there should be a 3D motion. It's a 3D motion. So remember that whenever the rolling spherical pair is used, that is used for a 3D motion. Similarly, next we have a higher pair. The second example is here, higher pair. So higher pair always make here line or point contact. Line or point contact. It means a wrapping pair. Line or point contact means it's a wrapping pair. That is also, it is named as a wrapping pair. Like example, we can say that, for example, there's one slider is there which is sliding inside the surface. This is your slider. So this slider is making here, it's a point contact with the surface. It's a point contact. So slider we can say that, or else we can say that cam and follower is also one more example. Cam and follower. This is here for cam is there, and the follower I'm going to assume that it's a roller follower. It's a roller follower. So this roller is rolling over the cam here. So this is called cam, and this is your follower. So this follower is just fixed in both the sides, and this follower is making here. It's a line contact. So it is example of higher pair. Next, we will see that chain. Next example is chain. What is meant by chain? And that chain is called it is kinematic chain. So the kinematic chain is defined as when the first link is connected to the last link. When first link is connected to the last link in order to have closed chain. In order to have, it should be closed chain. So closed chain is the first and last. It should be connected, and correlative motion should be only one direction, and the relative motion between the links should be constrained. That is in one direction. That is called here kinematic chain. Kinematic chain. And it's a constraint means that can be a mechanism. That will be a mechanism. And mechanism means it's a my machine. Mechanism means machine. That is a desired output. You will get it here output. And that output will be desired output. Like I have a kinematic pair. I will attach them so that I'll get a mechanism. And that mechanism should have move only one direction. So in that way you can get it here a machine. Next, the important thing is degree of freedom. In that only it will come degree of freedom. So the definition is, and it is also known as here, remember that it's a mobility. And the definition is the minimum number of the minimum number of independent variable required to define the position and motion of the system. Required to define motion of the system is known as degree of freedom. Like we will, like here I will tell you that, like this is the 3D, that is a space user, that is this is X, Y, and Z, and this is here object user, like a 3D object I'm assuming. So this object can move in X direction or it can translate. Can move in Y direction or it can translate. Can move in Z direction or it can rotate also. It cannot translate, it can rotate also. Rotate also. So there is a 3 translation motion and 3 rotation motion. 3 translation motion and 3 rotation motion. So maximum number of motion in a space, it could be maximum number of motion. And there is a 3 translation and 3 rotation motion. So in that only, I will try to find out the degree of freedom. So the degree of freedom is defined as 6 minus restraint motion. 6 minus restraint motion. Degree of freedom is nothing but it's a restricted motion. Restricted motion. Like if any body is restricted in one direction, so I can say that the degree of freedom will be 6 minus 1, that is a 5. That is a 5. What do you mean by here restraint? Restraint means number of those motions which are not possible. Restraint motion means those motions which are not possible. And restraint is also known as constraint. Restraint is also known as constraint. It means two systems in the form of pair. So which are not possible, that is called restraint motion. You need to subtract from 6. You need to subtract from 6 here. So here we'll check it here. Like one side I'll check it here pair. And here I will give you that restraint motion or restricted motion. And here I will write down the DO. Like first I'm going to assume that this type of link. This is the link 1 and this is the link 2. So this is a turning pair is there. So here how many restraint motion is there? How many restraint motion? So this is the turning pair means it can turn. It can only rotate in this direction, correct? It can rotate. Like one link, it can rotate like that. So I can say that there is a 3t plus 2r. These are the restraint motion. In total, 5 are the restraint motion. And it's moving only one direction. I can say that if there is a movement in one direction, that is a DOF is also will call it as a movement in direction. And if there is a 2 direction is there, then the degree of freedom will be 2. If the movement is only one direction, the degree of freedom is 1. Or else we'll do that 6 minus 5. Because there is a restricted motion is 5, so 6 minus 5 is 1 is the degree of freedom. Similarly, so just ulta, like if you assume that here it's a sliding pair like that. So I can say that if this is a sliding pair, so in how many directions it can restrain? So restraint means there is only one direction. But it can't translate. It can translate. It means the 6 minus 1 will be the 5 degree of freedom. Yeah, otherwise you need to think that if this type of diagram is there, this diagram can rotate or translate in how many directions? It can translate or rotate in how many directions? So I can say that total 5 डायरेक्शन में इसका मूवमेंट होगा. Total 5 डायरेक्शन में इसका मूवमेंट होगा. It means the degree of freedom will be 5. Or else we have a formula also. Based on that, like I will give you the formula to find out a complicated link. Like we have a degree of freedom formula is like by Pushback criteria. Pushback criteria. The degree of freedom is given by pushback criteria is F is equal to 3 into L minus 1 minus 2J minus H. This is the formula. Where L indicates that number of links, J indicates that it's a binary joint. It's a binary joint. Binary joint means this is called a binary joint. If 3 links are generating from one point, this is called tertiary joint. Tertiary joint, and this is here binary joint. In tertiary joint, there will be 2 binary joint. Or if it is a quaternary means like that. In quarterly, there will be 3 binary, 2 tertiary, and 1 quaternary. In that, there is 1 tertiary and there is 1 binary. So this is the binary joint, or we can say that just joint only. And the H indicates that it's a higher pair. कितने higher pair होंगे? Higher pair means line or point contact. So this equation is known as your pushback criteria, and इसका एक simplified version है. Simplified version that F is equal to 3 into L minus 1 minus 2J minus H minus FR. So here the FR is known as number of those motion which are not in the part of mechanism. Those motion which are not in the part of mechanism. So we'll check it here all, and based on that, like first of all, I am assuming that 3 links, like mechanism is possible or not. Like 1, 2, 3 links are there, and joint, how many binary joint? So 1, 2, 3 joint is there. So link 3, joint 3, and there is a higher pair? No. Higher pair when it becomes? When there is a slider is there, or follower is there, or roller is there, तब वहां पे higher pair आ सकते हैं. Then higher pair will come. So we'll check it here. 3 into L minus 1 minus 2J minus H. So in that the higher pair is 0. So 3 into 3 minus 1 minus 2 into, so it's 2 3 is 6 minus 2 3 is 6. See, the degree of freedom is 0. It means अगर degree of freedom is 0, it means no motion. कोई motion ही नहीं है. And if there is no motion means this is called a frame और structure. और जो ब्रिज में जो फ्रेम दिए जाते हैं, ब्रिज का कंस्ट्रक्शन होता है या फ्लाईओवर का कंस्ट्रक्शन होता है, उसमें कोई मोशन नहीं होता लिंक में. सो इफ डिग्री ऑफ फ्रीडम इफ यू आर गेटिंग अ 0, सो दैट इज कॉल्ड योर फ्रेम और स्ट्रक्चर. बट इफ यू आर गेटिंग अ डिग्री ऑफ फ्रीडम इज 1, this is called a mechanism. Degree of freedom is 1 means there is a motion of the link is there, that is in one direction. That is in one direction. And if the degree of freedom is more than 2, that type of structure is called superstructure. like it's a more than movement in more than one direction. So next we will check it here another column. Okay, so next we will take an example for 4-bar chain mechanism. How many links are there? 1, 2, 3, 4 links. And how many binary joints? It's a 4 joints. So the degree of freedom we can say that 3 into 4 minus 1 minus 2 into 4. So it's a 3 3 is a 9 minus 8 is 1. So degree of freedom as getting 1, it means it's a mechanism. With if this is a 4 type of 4-bar chain mechanism, yes, this is called a 4-bar chain mechanism. So here we can say that the minimum number of links it should be 4. Next, I will take example for cam and follower, or else we'll take it here this is the crank is here. This is the connecting rod. This is the frame, and there's a one slider is there, and this slider is sliding over there. Then what is the degree of freedom there for that? So first of all, count the number of links here. So this is the one. This is the link 1, and this is the link 2. This is the link 3, and this is the link 4. Link 4, and there's the slider is sliding over that. So there is a surface contact. It means the higher pair is 1. How to count the number of links? So there is one link, and this one is another link, because this is actually, it should be like that. It should be like fixed. It should fixed. It should fixed. It should be like that. So this is the one, full one. This is the 2. This is the 3. And there is one joint here is there in between these two. And there is a higher pair there, so that is 1. Now how many joints are there? So 1 binary joint, 2 binary joints, 3 binary joints, and okay, 3 binary joints is there. The binary joint is here. Okay, one here. Okay, one more is here at this point. The binary joint is here at this point, because this is the slider is there. So here also one more binary joint. It's a total 4 is there. So we can say that the degree of freedom is 3 into L minus 1 minus 2 into J minus H. 3 into 4 minus 1 minus 2 into 4 minus 1. So 3 3 is a 9 minus 2 4 is a 8 minus 1. So I can say that here the degree of freedom is 0. No. There is something wrong is here, because it's a mechanism is there. The mechanism means I think the joint is joint number is 3 here. If I take it here 3, so 3 3 is a 9, 9 minus 6 minus 7, 9 minus 6 minus 1. It's a 2 degree of freedom. So 2 degree of freedom means it could be here double rotation also. And it means the link is moving more than one direction. More than one direction. Next, I will check it here, cam and follower. Like this is here, cam is there, and over that follower is there. Follower. And this is here fixed. And this cam is fixed at this point. Then how many links are there? In that the link is 3. How to count it here? This is the one. So this is also 6 means this one also you count it 1. This is the two and this is the two, because these two are connected. So this is the one link, and this is also in the motion. So this is another link is three. Even the joint is also three. Like one joint is here, another joint is at this point here, and another is between these two. Between these two, joint is also three. And the higher pair is how many are there? So here the higher pair is one. Why? Because this one is moving over that. It's making here a line contact. Line contact. So we can find out the degree of freedom is 3 into 2 is 6 minus 2 into 3 is 6 minus 1. So minus 1. See, if you are getting here minus 1, it means, just a minute. Okay, here the joint is only 2. The joint is 1 is here and the 1 is here. The joint is only 2. So 2 is a 4. 4 plus 1 is 5. 5, 6 minus 5 is 1 here. So degree of freedom I am getting here 1. It means this is the mechanism. This is the mechanism. Similarly, you can take it for a lots of questions, like we have a question like that. And this is a sided portion. Now you need to tell me that how many, what is the degree of freedom for this one. And this part is just fixed. It's a fixed like that. So fixed one is assume that one link. Now count it 2, 3, 4. And this shaded portion is assume that one link. This shaded part is assume that one link, because it's a totally fixed. It won't move. It's a totally rigid. It's a fixed means one link here. So total how many links are there? 5 links. Joint is, so the joint is 1 here, 2, 3, 4, 5, 6 joints. So the degree of freedom is 3 into L minus 1 minus 2j minus 6. So 3 into 5 minus 1 minus 2 into 6. So 4 3 is 12, 12 minus 12. So 0. No motion. Motion ही नहीं होगा. No motion. So these are the here like degree of freedom, how to find out for that one. And you need to assume that for the shaded region, that one you need to assume as a one link. As a one link. After that, there is one more Grubler criteria is there. Grubler. What is this that actually Grubler? Grubler equation. That is derived from Pushback criteria. Like if the degree of freedom is 1 and the higher pair is 0. So the F is equal to 3 into L minus 1 minus 2j minus 0. So you substitute here 1. It's a 3L minus 3 minus 2j. So from here we can say that the 3L minus 2j minus 4 is equal to 0. So 3L minus 2j minus 4 is equal to 0. It means now to get the value equal to 0, or 3L is equal to 2j plus 4. 2j plus 4. So see, the 3L is always even number. It should be always even number. Why? Because this is here even number. This is here even number. Because it's a multiple of 2 means it's even number, and you are adding even number. So even plus even is always even here. So 3L is even number means minimum link should be what? So I can say that the link should be always even also. So the L minimum, yani minimum link कितना होना चाहिए? So see, if you take it here, L is equal to 1, odd you will get it here. 2 also if you got it here, odd. 3 if you take it here, no, 3 to just 6, even you will get it here. 3 3 is a 9, it's a odd, and 4 is a even. 4 3 is a 12, 12 means it's a even. So see, the 2 link we can't consider that. 2 link you won't get it mechanism. So minimum link it should be here 4. Minimum link it should be 4 to get the mechanism. To get the mechanism. That's why हम लोग जो start करते हैं mechanism पढ़ना, वो हम लोग start करते हैं 4 बार चेन मैकेनिज्म, 4 बार चेन मैकेनिज्म, नेक्स्ट हम लोग डिस्कस करते हैं सिंगल स्लाइडर क्रैंक मैकेनिज्म, and third is here double slider crank mechanism. तो हम लोग और तीनों चीज पढ़ेंगे, यहाँ पे डिस्कस करेंगे तीनों चीज। लाइक विल स्टार्ट फर्स्ट ऑफ ऑल 4 बार चेन मैकेनिज्म, एंड मैकेनिज्म होने के लिए क्या क्राइटेरिया होना चाहिए, दैट इज गिवन बाय ग्राफ ऑफ फ्लो। तो वो भी हम लोग डिस्कस करेंगे जस्ट नाउ ओनली।